Okay, um, this is going to be our first video in a review of fractions. I say first, I'm not sure at this point if there'll be others. I try to keep these videos around 10 minutes, otherwise they get kind of longish and whatever. I think it's easier to take bite-sized pieces. But for the sake of continuity, maybe this one will run longer. I don't know. We'll see. I don't edit these things, do any post-production editing, so what you see is what you get. All right, so let's, and I'll be kind of neat here. Let's get a circle out here. We'll pretend that that's a perfect circle. And let's let this represent the whole of something. Now our topic here is fractions. And fractions are generally a numerical representation of something less than the whole of something. So we're talking about something less than 1. All right. So let's take a look. One of my favorites, 2/3. And let's talk about what this really means. We have a tendency when we see fractions to look at them like any other number, like 5, 7, 56. It's just a number. Not quite. Not quite. Well, what do you mean? That's a number. Well, yeah, it's got numbers in it, but let's look at the parts. We have a numerator, and we have a denominator. Again, I'm not crazy about jargon, but sometimes you need a little bit in order to understand where some of this stuff comes from and what it means. And there's this all-important line in the middle, and it has a proper name, vinculum, but let's just call it the fraction bar. It actually is the operator for division. This means 2 divided by 3. That's why I say a fraction is not exactly a number. It is a pending math operation. It would be akin to, and I'll put it in parentheses so you can think of it as a unit, 3 plus 5. And I give that to you as a number. And it might be more obvious to you to say, okay, yeah, it's got numbers in it, but you're telling me that these two need to be added together, and I'm going to get 8. Now, 8's a number. If I give it to you in this form, it's a pending addition problem. Okay. So that's really what fractions are. And it's that property that makes them a little bit peculiar to deal with. Instead of dealing with exact numbers and doing some operation on it, they're giving us an operation that hasn't been completed. Well, why haven't they completed it? Why do we need homework here where we have to do some arithmetic? Well, some fractions can have an exact decimal number equivalent. This is an example of a fraction that does not have an exact decimal equivalent. If we do 2 divided by 3 on our calculator, we get this 0.6 with a line over the top. And calculators who actually spit out some number of digits will probably give you something like 0.666, and these 6's go on for a while, and the calculator will round up the last number to a 7. But in reality, what this is telling us is that these 6's as a decimal part, they go on forever. It's a repeating non-terminal decimal. Now there's a mouthful. You don't need to remember it. I'm just telling you that fractions don't always have an exact value. Other fractions do. For example, 1/4. This can be expressed as the decimal number 0.25. And that's the end of it. This is an exact value. This is an approximation. Okay, let's get back to what this means here in our picture of a whole and what that's all about. So what do these mean? Well, let's start with the denominator. And always remember denominators on the bottom because it's down, and denominators both down and denominator start with a D. So the other one's up on top. So let's divide this up into 3 equal pieces because that's what the denominator says. We'll pretend that those are all equal. This tells us that the whole that this thing is representing has been divided into 3 pieces and that we have 2 of those pieces. That's why fractions are ratios, ratios are fractions, fractions are rational numbers. Remember, rational and irrational have the word ratio in them? Okay. So it's a ratio, 2 to 3. And when we talk about decibels and power and voltage ratios, notice that word ratio pops up all over the place. Okay. So that's what it is. The bottom number tells us how many slices the whole of something has been sliced up into, and the top number tells us how many of those we have. Now, doing arithmetic with fractions in some areas is tricky. The easiest thing to do with fractions is multiply them. So let's take our friend 2/3 and let's multiply it by 1/2. And in multiplying fractions, it's just the top number times the top number, the bottom number times the bottom number. You'll get another fraction. 2 times 1 is 2, and 3 times 2 is 6. So we get 2 over 6. And since this can be reduced, 2 goes into 2 one time, 2 goes into 6 3 times, we can reduce that fraction to 1/3. Many teachers will beat you over the head if you don't reduce your fractions. There is nothing wrong with this fraction. It just can be expressed with smaller numbers. Okay, but notice that information is different. This tells us that we have a whole divided up into 6 pieces, and we have 2 of those. This tells us we have a whole divided up into 3 pieces, and we have 1. Numerically, they're equivalent, and that's really all you need to worry about. But notice that chopping things down and reducing them does so at the expense of detailed information. Okay. But that's not even the big whoop here. I want you to take a look at the 2 things that we multiplied together. And when you're multiplying and dividing, those things that you multiply and divide are called factors. So 2/3 and 1/2 are factors. So we have 2/3 and 1/2. And look at the answer. This is one of the things I think is a little counterintuitive. When we multiply stuff, we expect the answer to get bigger. When we divide, we expect it to get smaller. Notice that our answer here of 1/3 is smaller than either the 2/3 or the half. So the behavior, looks like it's kind of opposite here. So watch that. Okay. And we're getting up on 10 minutes here. I think at this point I'll stop, and in the next video we'll take a look at dividing a fraction and then look at adding and subtracting them. All right, see you then.